Problem number 12 tests you on the order of operations, and the memory aid a lot of students use is PEMDAS. Let's briefly try to understand why we need the order of operations. So a simple example would be the following. Let's say you see this 3 plus 4 times 5. Now it's reasonable to say 3 plus 4 is 7, and 7 times 5 is 35. It's also reasonable to say I'm not only adding 4 to a number, in this case 3, but I'm also multiplying 4 by a number, in this case 5. So let's do that first. Let's multiply 4 times 5 to get 20, and to that add 3 to get 23. Now obviously these cannot both be right, so the order of operations demands that we do this type of a problem or any arithmetic problem in a certain order so that everybody gets the same answer. And we'll see as we proceed that in this case the proper answer is 23. Now let's look more closely at the order of operations. The beginning letter here is P, which means parentheses, but there's little more to it than that. When we say parentheses, we mean we do that first if there's an operation inside the parentheses. What this lets us do is override the normal order of operations. In other words, you see there's a sequence here. We do exponents and then multiplying and then adding, but let's say we want to do them in a specific order that we want for a particular problem. Well, that's where parentheses come into play, and we'll see that as we examine the various problems. So again, the P for parentheses lets us override the default of operations, and it's what we use when there's an operation inside the parentheses. The next is exponents. If we see an exponent, we do it. Next, now these are a lot of students may have come up with a mistaken idea of what takes place here. Even though we say here P, E, M, DOS, M preceding D, the M and the D are treated equally, and that's why they're at the same level here. And they're done left to right. I don't care whether multiplication is first or division is first, whatever. We do them left to right as they occur. And similarly for adding and subtraction, just like with multiplication and division, I don't care which one comes first. I do them all as I see them left to right. So problem number 12a. We see there are two operations going on. The first one is subtraction, and the parentheses indicate multiplication. So the order of operations demands that we multiply first. So I'm going to say 7 minus, I'm not subtracting yet, so the 4 is being subtracted, the 4 is being multiplied, so I have to multiply first. So 4 times 5 will give me 20. And now there are different ways to handle subtraction. The way I like is to turn it into an addition problem and then use the rules for addition. So when it says 7 minus 20, it's really 7. This 20 here is, you don't see a sign there. The sign, this negative here is subtraction. So it's 7 take away a positive 20. So we'll turn that into an addition problem, and we change the sign of the second number. So now you have 7 positives and you have 20 negatives. Combining these, well, we see that the negatives went out by how much? By 13. So that would be the answer here. In problem 12b, we see we have addition. And we have an operation inside parentheses here. So this time we do have a P, and the operation is subtraction within that parentheses. And then finally at the end here we have an E, an exponent. So the order of operations demands we do parentheses first. So I'll just copy the 13 plus, and as we saw in A, we're going to treat subtraction as an addition problem. So it'll be 5 plus a negative 9 Now we have 5 positives. We're combining it with 9 negatives. The negatives went out by 4, which is being squared. So we did the P. Next in PEMDAS's E, we have an E. So 13 plus negative 4 times itself twice. You remember when you multiply a negative times itself, when the signs are the same, when you multiply, the result is positive, 16. And 13 plus 16 is 29. Now, in case some of you are having difficulty understanding why 5 plus a negative 9 is negative 4, let's put some pluses and minuses into my little magic box here, and we'll see why. We have 5 positives, 5, so I'm going to place 5 positives into the box. And we're adding into that 9 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see that there are 5 positives and 5 negatives that offset each other. And we're left with 1, 2, 3, 4, 4 negatives. So I hope that helps. Problem number 12C, we see we have division, multiplication, and subtraction. Which shall we do first? Well, in the past you might have thought we do multiplication first because P-E-M, M precedes D, but we know that's not right. We know when it comes to multiplication and division, we treat them equally. We perform the operations left to right for multiplication and division. Whichever one occurs first, we do. So here, since division occurs first, we'll do it. So 24 divided by 6 is 4. We still have the times 2 minus 19. I do one operation at a time just to keep this simple. 4 times 2 is 8 minus 19. So we did the multiplication first on this line. Now we're going to treat subtraction as addition. So it'll be 8 plus. We see we're doing here 8 minus 19, which means 8 minus in the circle. See a positive 19. So when you change it into an addition problem, you also have to change the sign of that second number. So now we're combining 8 positives with 19 negatives. The negatives went out by 11. What are the operations in 12D? We see subtraction. Now, if you say this out loud, what the problem is, you're saying 15 subtract a negative 4. So there's no operation here. This is with the negative 4. That's just a number to subtract. So you're subtracting. 15 subtract negative 4. And we're adding to that a negative 41. So the two operations are subtraction and addition. So what letter is up to do first? You might say P for parentheses. You see, I did not specify a P here. Why not? Because P only applies when you see an operation inside the parentheses. Here there's just a -4 in the parentheses. So that's why there's no p here, or with a -41. So just like with the previous problem, part C, when we were multiplying and dividing together, here we're subtracting and adding together. And once again, you do not determine which one goes first by A or S because of the order you see them in PEMDAS here or in the chart here, but rather they're treated equally as you see right here, and we proceed whichever one we see first. That's the order. So we go left to right. So we'll subtract first here. So we'll get 15, turn it into an addition problem, change the sign of the second number, and we'll bring down the rest of this. Now we only have addition left. 15 plus 4 plus a -41. 15 plus 4 is 19 plus a -41. So you have 19 positives, 41 negatives. Which sign wins out? That's right, the negatives win out. By how much? Well, we want to see how many more negatives than you have than positives. How do you determine how many more or how much more of something you have than of something else? You subtract them. Just like we saw in part C. So we'll go 41 take away 19. And you'll see that here we get 22. So we have 22 more negatives than positives. And so the answer for part D is -22. So let's proceed to part E. I have to scroll down, so I'll rewrite the order of operations. So in part E, we begin with a subtraction. We have parentheses here. We have an operation within the parentheses. We have an exponent. We have addition, and we wind up with multiplication. So there's a lot going on here. So of course we'll begin with P. 31 minus, we're not doing subtraction. So 7 take away 11, 7 plus a -11. And we'll just write the rest of the line. 31 minus 7 positives and 11 negatives. The negatives went out by 4. Now we have subtraction here, exponent, addition, multiplication. So PEMDAS, we'll do the E next. 31 minus. Now -4 times itself twice. We've seen already is positive 16. Now let's look. Subtraction, addition, multiplication. So multiplication will be next. We're not adding here. We're going to multiply the 2 times the -9 to get -18. 31 subtract 16. 31 plus a -16 plus -18. So all we have left is addition. So 31 positives adding in 16 negatives. The positives went out by 15 plus -18. So you have 15 positives, 18 negatives. Add them together. The negatives went out by 3. So the final answer for this part E is -3. I hope you have been trying these problems before you watch how I go about solving them, because you'll benefit much more if you do that. Okay, part F, we have subtraction, multiplication, division and addition. So we will have to do the multiplication and division. We'll do them left to right. 16 subtract. So 8 times 4, 32. Now we see we have subtraction, division, and addition. So the division will be first. 16 subtract 32 divided by 2. 16 plus a negative 8. Now we have left subtraction, addition. We do those left to right. 16 minus 16 is 0 plus negative 8. Now 0 added to any number just does nothing, right? We just still have the other number. So the final answer here is going to be negative 8. Part G, we have addition, multiplication, and we have parentheses with subtraction going on. So the parentheses have to be taken care of first. And even though this is a subtraction problem, I think you can do this in your head. Don't need to do the formal way we've been changing subtraction and addition, I think, for something like this, because I think everybody knows 5 take away 2 is just 3. So we have left addition and multiplication. Multiplication wins out. So 19 adding 4 times 3, or 12, and 19 plus 12 is 31, which is the final answer. So that was pretty easy. So we'll finish problem 12 with part H. We have subtraction. We have parentheses with subtraction. We have exponent and addition. So we'll do the parentheses first. 31 minus 5 plus a negative 8 to the second power squared plus 7. Finish off the parentheses. 5 positives adding in 8 negatives. The negatives will win out by 3. Subtraction here. Exponent addition. We'll do the exponent next. 31 minus negative 3 times itself twice. The sign will be positive. 3 times 3 is 9. Plus 7. We have left subtraction and addition. We'll do these left to right. 31 take away 9 will be 22. 22 plus 7 equals 29. Problem 13 asks you to order the given fractions from smallest to largest. Now, in order to compare fractions, each fraction has to have the same denominator. If they do, then you determine which one is smaller, which one is larger by comparing the numerators. If the denominators are not the same, then you need to make them the same. What you do is you find the least common multiple, which we call the LCM, and then create equivalent fractions with that least common multiple. At that point, when they have the same denominators, you compare the numerators. I see in part A, the denominators are all different. So I'll have to find the least common multiple and use that as a common denominator for all the fractions. So the way you find a least common multiple is you look at each denominator in turn and you take multiples of that number, and you want to find what multiple of each denominator you could make such that you would find a common multiple. So 2 multiples of 6 are 12, 3 multiples of 6 are 18, and I could keep going, but I see that the next fraction has the denominator of 9, And I see that 2 multiples of 9 would be 18. And clearly I can get 18 from 2 because 2 is an even number. And if I take multiples of 2, keep taking them, eventually I'll get to 18 again. So it looks like 18 will work. Let's check the last denominator. It's 3. So multiples of 3, 2 3s are 6, 3 3s are 9. And once again, I get to 18. So clearly, 18 is going to be the least common multiple. Now I want to label each fraction so I can easily refer to the one that I'm working with. Now, we're going to create equivalent fractions with our LCM. So the first fraction is, so we started with 5/6. Now you need to get 18 in the denominator. So if I multiply 6 times 3, that will give me the 18 I need in the denominator. But what I do to the denominator, what I multiply by in the denominator, I have to do in the numerator, and the result will be 15 over 18. So the equivalent fraction for 5/6 is 15/18. And now let's go through the same process for 4/9. You see that we start with 4/9. I look at the 9 in the denominator. I need to multiply it by 2 to get 18. I multiply the 4 by 2 as well, and I get 8. So 4/9 is equivalent to 8/18. And similarly, I'll do C. 1/2, I multiply 2 times 9 to give me the 18. So I multiply 1 times 9. And finally, I'll multiply the 3 times 6. That's what I need to get 18, and therefore I multiply 2 times 6 to get 12. So I now have my 4 equivalent fractions. I'd like to add one more thing at this time. If there's any doubt as to whether 5/6 really equals 15/18, you should see and realize that you could cross out the 3 and the 3 in the top with the 3 in the bottom. And if you do that, you'd be left with 5/6 is what we started with. Remember, whenever you have something that's multiplying something else in the numerator, and that same something, in this case the 3, multiplying something in the denominator, they can be crossed out. So when you cross them out, you get 5/6. When you multiply by the 3, you get 15/18. And the same is true for each of our fractions. So now we're ready to compare our fractions. B is the smallest fraction. I'll call that number 1 because it has the smallest numerator. C would be the next smallest because it's 9. The next smallest would be D. And finally, the largest would be A. Again, we're comparing numerators, and from smallest to largest, we went from 8 to 9 to 12 to 15. Now the choice on the test, or the choices on the test from which you'll have to choose, will not have your equivalent fractions as choices, but what we started with. So the answer will be, here's number 1, so the answer will be 4/9, because that's what its equivalent fraction is, followed by 1/2, followed by 2/3, and finally 5/6. So this sequence from smallest to largest is the answer. Let's begin working on part B. Well, we see the denominators are different, so we're going to have to find the LCM as we did in part A. I'll write down my denominators: 12, 8, 4, and 6. 2 multiples of 12 or 24. Now, I could keep going, but once again, I see that on the next line I have 8, and I know 8 times something gives me 24. I know 2 multiples of 8 are 16, 3 multiples of 24. So far, 24 looks like a good candidate. 4, 2 multiples are 8, 3 multiples of 12. I see each time I'm adding 4, 16, 20, 24. And 6 will work as well. 2 multiples of 6 are 12. Another 6 is 18. And finally, 24 once again. So we see the least common multiple is 24. Now let's label each of our 4 fractions. So let's make an equivalent fraction for fraction A, 7/12. So we need to get the LCM of 24 in the denominator. So therefore we're going to have to multiply 12 by something to give me what I need, 24. So we see that 12 times 2 is 24. So we have to multiply the 7 by 2, and we get an equivalent fraction of 14 24ths. Proceeding to fraction B, my fraction is 3/8. The equivalent fraction will have a denominator of 24. So I see I need to multiply by 3 this time. And we get 3 times 3, 9 24ths. Proceeding to fraction C. Fraction C is 3/4. We need to multiply the 4 times what to get 24. That's right, we're going to multiply by 6. So we'll multiply the top by 6 as well. And 3 times 6 is 18. Finishing with D, we have the fraction is 1/6. So in this case, we need to multiply the 6 by 4 to get 24. So we'll multiply the 1 by 4 as well, and we'll have an equivalent fraction of 4 24ths. Now let's order these in the proper sequence from smallest to largest. We see that the smallest fraction is D, because it's only 4 24ths. Getting larger as we proceed upwards, we get B, that's 9 24ths. A is 14 24ths, and the largest is C, 18 24ths. So now it's time to write the answer, and the answer is going to be based on the original fractions. So the answer will be, number 1 is 4 24ths, which corresponds to 1/6. Fraction, or equivalent fraction, number 2 was 9 24ths, but that corresponds to 3/8. Number 3, we'll use 7/12. And number 4 is 3/4. So this sequence, which I'm now circling, is the final answer from smallest to largest. Problem number 14 asks you to order from smallest to largest the given numbers. Now I recommend for this problem you use what we call the real number line. And the real number line is a horizontal line, and on this line it goes infinitely far in either direction. It contains almost any number, every number you can think of. Now as we go in this direction, the numbers decrease. As we go in this direction, the numbers increase. So I'm just going to write a number here, the first number we're given, -3. Now, where does -2 go? We know as we go to the right, the numbers increase. As we go to the left, the numbers decrease. Now, you have to be careful here. You might think that 2 is less than 3. That's true. but we have signs here. So the first number is -3, 3 negatives. Now we only have 2 negatives. So 2 negatives is actually greater than 3 negatives, and so we place -2 to the right. It's larger. We've increased. Next is 4. Well, we know 4 is certainly larger than a negative number, so I'll place 4 over here. 0. Well, we know 0, that's not positive nor negative, so it's going to be between the negatives and the positives. And finally, -1/2. So it's going to be negative, so it'll have to be to the left of 0, but it's certainly less negative than 2 negatives. It's only a half negative, so we'll place it over here. And if we read from left to right, that is the sequence we're looking for. That is the sequence where we see numbers are increasing from smallest that they gave us to the largest. Problem number 15 asks you to evaluate the two fractions, a and b, each of which contain 0. A containing 0 in the numerator and b containing 0 in the denominator. Now, a lot of students remember that the answer is either going to be 0 or the answer will be undefined. And they try to memorize which example will correspond to which. Now, you really don't have to memorize this. Let me show you why. For instance, let's say we ask you to divide 6 by 2. And you would say, I know that. That's 3. Okay, no problem. So the answer is 3. But could you prove it to me? How do you check a division problem? Well, you check it by multiplying. So if 3 is correct, it must be that 2 times 3 gives me 6. And it does, so we know 3 is correct. Now let's see if that can help us for our problems. Let's start with A. So we're asked to divide 0 divided by 3. So whatever the answer is, we know that 3 times that number must equal 0. So 3 times what equals 0? Well, the answer is 0, right? Because 0 times any number is 0. So we feel confident that the answer is 0. Now let's go to part B. Let's say again, what is the answer? 0 times what equals 3? Well, we saw in part A that 0 times any number is 0. We want the answer to be 3. So no matter what answer we put here, the answer has to be 0. So there's no answer. Well, in math, when there's no answer, we say the answer is undefined. Problem number 16 asks us to express the answer to the division problem 613 divided by 80 in two forms. One as a decimal and one as a mixed number. When they ask you to find or put the answer in the form of a mixed number, what we'll be doing is looking for the remainder to then form the mixed number. 80 into 613. So 80 into 613, I'm going to put zeros here. I don't know exactly how many I need, so I'll just put a few here and see what happens. And we have to align the decimal points. Now there are no 80s in 61, but of course there are 80s in 613. And I see that there's going to be probably 7. Now where did I get 7 from? Because I see 7 times 0 is 0, and then 7, and then some number times 8 is going to have to be as close as I can to 61. So 7 times 8 fills the bill. So 7 times 0 is 0, and 7 times 8 is 56. Now we subtract. 3 minus 0 is 3. Now at this point you're going to have to borrow, so 6 becomes 5, and we put a little 1 here. So now we have 11 take away 6, and 5 take away 5 is 0. So at this point, if we were calculating the mixed number portion, we'd have all the information we need, because we do not go past the whole number part of the answer. We do not go into the decimal part of the answer. So the mixed number answer would be 7, because a mixed number consists of a whole part, and the remainder, the denominator is going to be the divisor, the number on the outside here, and the numerator will be the remainder we got. So that's going to be 7 and 53/80ths. Now to get the decimal part, we continue. We'll bring down the next digit, which is a 0. And now we'll try 80 into 530. 80 into 530, this time 7 we know will be too much, because that would be 560, but it's not off by too much, so let's try 6. So 6 times 0 is 0, and 6 times 8 is 48. We'll subtract. 0 take away 0 is 0. And once again we have to borrow. So take 1 away from 5 to get 4. Put a little 1 here. So 13 take away 8 is 5. And we bring down the next digit, the next 0. 80 into 500. Well, we know 6 times 80 is 480 from what we just did, and that's pretty close. So we'll try 6 again. We'll get 480. We'll subtract. 0 take away 0 is 0. We'll borrow. 5 becomes a 4. Put a little 1 there. 10 take away 8 is 2. 4 take away 4 is 0. So time to drop down the next digit. Another 0. 80 into 200. Well, 3 times 8 would be 24. A little bit too big, so let's try 2. 2 times 0 is 0. 2 times 8 is 16. 0. We borrow. 2 becomes a 1 and a little 1 here. 10 minus 6 is 4. Bring down the next 0. Now you may be wondering, how far do we have to go? Well, they did not ask you to round here, so they do expect you to be able to answer the problem in 3 minutes, so we better be getting pretty close to the answer, so don't get worried or frustrated. Alright, 80 into 400. So we know we have to have whatever we put here, when we multiply it times the 8, we're going to have to get 40. So that's going to be 5. 5 times 0 is 0. And 5 times 8 is 40. And we're done now because there is no remainder. So the decimal answer is 7.665. And once again, I cannot stress enough the importance of learning your multiplication tables. Learn your multiplication tables. Speaking of multiplication, let's do problem number 17. I've written the problem vertically because most people find it easier to do multiplication that way. So 9 times 8, 72, put down a 2, carry the 7. 8 times 3 is 24, plus 7 is 31, carry 3. 8 times 7, 56, plus 3, 59. Now we're ready to multiply the next digit, and as I think I mentioned, I like to erase the previous carry digits to avoid any confusion. So we have to indent a column, and it's certainly easy to multiply by 0. So 0 times 9 is 0, 0 times 3 is 0, and 0 times 7 is 0. Now we multiply the 5, and we indent again. 5 times 9 is 45, carry 4. 5 times 3 is 15, and 4 is 19, carry 1. 5 times 7 is 35, plus 1 is 36. Adding this all together, 2, 1, 9 and 5 is 14, carry 1. 1 and 5 is 6, 6 and 9 is 15, carry 1. 1 and 6 is 7, and we have the 3. So the final answer is 375,412.